Since my last video, we have learned this technique called factor by grouping. And so I felt that it might be good to put a few examples up on the student portal so that you could remember these special cases. Now remember, when we do factor by grouping, we are basing our factoring method, and I'm going to write this here, by the distributive properties. So when we say that we have excuse me. When we say that we have A times B plus C equals AB plus AC, right? If we look at AB plus AC, this side of the equal sign, we see that these two terms, we have a binomial, and these two terms have a common factor, and that common factor is the A. So we are going to try to use this idea in our factor. But the first thing we're going to do is we're going to group. So we have four terms. So we're going to make sure that our polynomial is in descending order. And we're going to put the first two terms in one group. And this is our special case. In the second group, I see that the coefficient in front of y is negative. And so we know now that we're going to put that negative inside our parentheses, and then we're going to put a plus between the two parentheses so that we don't forget that we don't have a factorization here yet. We still have the polynomial that we have to factor. Okay, so then we look at this first piece. It says 4y cubed minus 7y squared. And we look at the two terms and we say, what is the greatest common factor? And actually, between these two terms, the greatest common factor is just a y squared. And what's left behind, what would multiply back to 4y cubed, would have to be a 4y. And what would take the y squared back to a negative 7y squared would have to be a negative 7. Okay, so we've just done the reverse of the distributive property, or I say we factored out the y squared. So now we're going to look at the second group, and we're going to find a greatest common factor between its two terms. And negative 16y and 28 have a common factor of negative 4. Thought I'd pause for a minute so you could think about it. Anyway, when we have this negative in front, we know that, and the highest power here is leading with a negative. We've talked quite a bit about how you want to factor out a negative sign. And so now if I have factored out that negative 4, it's going to leave me a positive 4y minus 7 in the parentheses. So if I multiplied this all back out, I'd get back to this blue polynomial. But actually, if I look at this, what I have is this term. Let me use color. I have this term, which is y squared times 4y minus 7. And I have this term minus 4 times 4y minus 7. So just like a times b plus a times c, here we have a times, we'll say that this is our a times b minus our c times a. What's the common factor between these two pieces in green? It's the 4y minus 7. 4y minus 7 is acting like a is in this description of the distributive property. So when we factor out the a, what's left behind? In our case, what's left behind is y squared minus 4. And so that is, at this point, it is factored. It is two terms multiplying together. So I look at the two terms and I say, am I completely factored? I think that 4y minus 7 has no common factors, so it's fine. But I see y squared minus 4, and we can see there that we have this difference of squares case, where we have an a squared minus b squared. And that comes from only from one other possibility. So we bring down our 4y minus 7, and then we know that y squared minus 4 factors to y minus 2, y plus 2. Okay, so at this point, we would say this is factored. When I ask for the zeros of the function, that's when we look at each one of the factors. For example, 4y minus 7, and we find the value for y that makes this factor equal 0. And in this case, y would be 7/4. Then we would also do y minus 2 equals 0, and we would find that y is 2, and finally y plus 2 is equal to 0, and so y would be -2. Now, in this problem, it's kind of counterintuitive that we used y as the variable, but we've talked a lot about functions in class, and we do know that actually whatever the output is, output in our graph, oops, that was a terrible line, in our graph represents, there we go. The output here represents y. Here is y and x. So we're looking for where the output for y is 0. So it's these numbers, 7/4, 2, and -2. It must be where this polynomial is actually crossing the x-axis at x equals 2, x equals -2, and x equals 7/4 would be 1 3/4, so it must do something funny like this. We don't know, but it crosses at those three places. Okay, I hope this helped you understand factor by grouping.